So what you actually do, first when you prepare the machine learning exam, you just take this file, first study these things, right? Now I ask you one question, just you say me yes or no alone. Don't want to say more than that. Say me yes or no on that. If a table like this is given to you, x1, x2, x3 like this is given to you, will you be able to find what is like R12? So what you will actually do is you actually just go and see this formula. What is given in this formula? R12 means summation x1 x2 divided by square root of summation x1 squared into summation x2 squared. Right? Given a table like this, just to try to compute R12, right? You first understand how to compute R12 and R23, R13 and so on, right? So what is R12? What is R12? Similarly, R13 means summation x1 x3 divided by square root of summation x1 the whole squared and summation x3 squared. So that is the thing. So you know how to calculate the initial thing. Now let me ask a single line question. What is R12? R12 is partial correlation or what is that? It is actually single order correlation or zeroth order correlation, I can say. This is actually zeroth order correlation. No partial correlation. Partial correlation will come only when dot is present. Am I right? 1, 2.3 means that I'm going to do correlation with respect to 3. That then only that are 1.23. Like that only partial correlation will come. See here, when I do partial correlation, it is 1, 2.3. Something if I ask you a question, if what is R12.3, you should be in a position to say what is independent here. R12.3 means what is independent here? Independent are 1 and 2, set of independent variables which is being kept constant. 3 is kept as constant, right? If I give you a question like R12.34, what are the constant variables here? If I give you 1 is constant, 2 is constant, 1, 2 is constant, 3, 4 is constant. What is constant here?
3, 4.
3, 4 is the constant here. Just to say the variables which is actually next to the dot, you say it as actually constant variables. Like this, the model is going to be studied from the independent variables 1 and 2 by keeping 3 and 4 as constant. So that is actually the partial correlation. Now, since 1, 2.34 until it is actually going like an 8 mark, 16 mark, it is actually you study the formula. But this 1, 2.3, in this case, do you remember the quiz we kept for machine learning, quiz 1? Do you remember that? There I gave one table, then I asked you to calculate R12. From R12, I asked you to calculate R12.3 and so on. Here, assume that I give you R12, R13, R23. Will it be possible for you to substitute this R12, R13, R23? Let me say, give some values, say R12 is equal to some 0.6, R13 is equal to 0.2, sorry, 0.4, not be that much deviated, 0.4, and R23 is equal to 0.5. R13.2 is nothing but R13 minus R12 R32 divided by square root of square root of 1 minus R12 square into 1 minus R32 square. That is R13.2. So you put R13. Next 13 is there now. So 1232. That is what R12 R32. Same what is R12 R32 here. You just put it here as 1 minus R12 square, then 1 minus R32 square. From this itself, you can write the denominator. Okay, are you doing?
So 0.208.
Yes, there will be some options. Okay, 0.208 is given by Tanush. Okay. Probably is given less than 1 minute usually inside the answer. So like that, you should be in the position to compute what is this. So similarly, I'll ask you some different questions. If I ask you like what is R12.34, right? Surely it will not be possible for you to compute from R1213. But if R12.4 like that it is given, by substituting in this formula you can do, right? This individual things
Yes, sir.
R12.4, 13.4, like that if I give, okay, that's the thing. But so the thing is you memorize all the formulas, understand everything. Understand what is the constant. T4 is constant, 1, 2 is going to be the variable terms, and those things you keep in mind and you actually understand those things. Next, what is the basic correlation is R12. This generally you have to keep in mind. R12 is the basic. Without R12, we cannot do anything. Now going to the multiple correlation, and like this only I'm saying, right? So this and all, this document will help you a lot. Right now going into the multiple correlation, R12 is 0.98 and R13 is 0.44. Right now I ask you a question. What is the difference between partial correlation and multiple correlation? Difference between partial correlation and multiple correlation. See, in the multiple correlation, we have keep R1 as dependent and 2 and 3 as independent. Whereas in partial correlation, what we do, we keep, if it is R12.3, what is the meaning for this in partial correlation? What is the meaning
Constant
for this?
is 3 and 1, 2 are
Independent.
dependent variables.
1, 2 are variables and 3 is a constant. Whereas R1.23 means 2 and 3 are independent, but 1 is dependent. That is, we are going to calculate 1 with respect to 2 and 3. That is what it's called as multiple correlation. Calculating 1 from 2 and 3. Right? It's these things. So you just understand the options and then you answer. Okay. So these also, study this formula also. So totally this is the sixth formula now. So study this formula also. What is R12, 1.23? That is R12 squared plus R13 squared minus 2R12, R13, R23 divided by 1 minus the thing, this particular independent terms. R23 squared, the whole square root. So study this also. Right? Is it clear? Studying these things?
Yes, sir.
Yes. So similarly, you understand how to calculate R2.13, R3.12, everything. Everything we have calculated and posted here. Nothing new. Okay. So with respect to correlation and correlation, see, we have this totally what the formulas. R12, that is simple correlation formula. That is zero order correlation, R12. Next, first order correlation, R12.3, R13.2, that formula. Then we go for multiple correlation, that is 1.23 and those things. We also go for the second order correlation, that is 12.34 and those things also. Right? Yes, these formulas are okay. And if it is just substitution and then answering, and understand what is constant, what is independent, and what is dependent. Right? This correlation and multiple correlation is easy and okay, right? Using this, you can study and write, right?
Yes, sir.
This is most important, okay? No, right? Shall I proceed to the next file? If you say, I'll
Yes,
proceed.
sir.
Yes. So
Yes,
when
sir,
you start
proceed.
machine learning, you first open this file, you study this, then going to the next one. Go to the course plan, we have after that missing data analysis and R squared and statistical significance. That is actually the next thing. Missing data analysis, we actually have like a PPT like structure there in IBM. I'll go for next problem, that is chi-square testing, right? This also, though many days happen, you may have slightly forgot. Let me recap those. So what are the things over here? A table will be given where observed values is this and frequency is this. So what does it means? There are, while throwing a dice, there are 6 possibilities and the frequency of each possibility is given. But what chi-square metric says? Chi-square metric says that there should be an uniform distribution. So what is the uniform distribution I can obtain? I add all these things like 25, 29, 19, 36, 32, 27, everything I add, I get 168. If it is uniform distribution, then what should be there? 168 divided by 6, that is 28. Each observation should get only 28 frequencies. So that is actually the expected values. Based on this expected values, I need to set whether the throwing the dice is fair or not. So now what I'll be asking you is, I'll be not giving you a very big table and all, I'll be giving a small table and I'll be asking you whether the hypothesis is true or not. I'll be saying the hypothesis. My hypothesis is dice is fair. So you should say whether dice is fair is hypothesis is true or alternate hypothesis is true. Like that you have to say. So what you will do, just to see the formula, what is observed values, what is expected values. Expected values you need to calculate. Next you find O minus E the whole square. Next include the chi-square metric formula. O minus E the whole square divided by expected. So do you total this, and this is what the chi-squared value. And for this chi-squared value, I go to the chi-square table and use the degrees of freedom, and with the significance level say 0.01, and I usually the significance level best is 0.01 to 0.05. You study this also. If I ask you what is the best significance level, you say between 0.01 to 0.05. I find in the chi-square value that the value is going to be 15.09, but my observed value is less than 15.09, so it is within my observed level. So I say that they are not, the hypothesis is accepted. Dice is fair, right? Like that, right? So just I will not. It is not possible for us to have these 16-mark questions in the MCQs. So just understand what is the core concept. So what is the formula for chi-square metric? If I ask, what you will say?
Summation of
Observed
1 minus
minus summation of observed minus expected whole square by accepted.
Great, great, very, very expected. And if I get the chi-square values, I'll be saying that the chi-squared value for the given distribution is 6.23, and with the degrees of with the number of observations 10, and significance level of 0.01. Right now, what you will be doing to say my hypothesis is true or not? See, something is given like 6.14 is the chi-square value. You need not calculate these things because this much big table cannot be given. So instead, what I'll give, I just give you the 6.14 is the chi-square value with 7 observations and significance level of 0.01. And I set a hypothesis, like some hypothesis I said. Now you have to say me whether this hypothesis is true, accepted, or rejected. So what you will be doing? Just very simple. This is actually the chi-squared value. Just for this chi-squared value, I'll be taking 6.14. Okay, the number of observations is 7. If number of observation is 7, degrees of freedom is 7 minus 1 equal to 6. And my significance level is given as 0.01. So with this significance level, I'll go to the chi-square table. In the chi-square table, for this alpha, for this degrees of freedom, what is the value? I'll be getting some value like 17 point something. And if I found that my chi-square value is less than the value in the chi-square table, then what I say, it is accepted. Otherwise, I will say it is rejected. Am I right? It is because you will not be able to do the entire table solving. Probably this will be given. And you need to understand what is the degrees of freedom. N minus 1 should be the degrees of freedom. What is N? N is the number of observations. And you will be given the significance level also. Right? Yes. The thing is, I'll openly saying many of some problems are there. So those problems you need to solve and you have to do. Only I'm saying. So if I give you a chi-square value, you just understand what is the degrees of freedom, what is the significance level, and check whether the hypothesis can be accepted or rejected. Right? The chi-square table test understandable? Yes. So one more thing, if I just ask you a question, let me see how many of them can answer. What is the difference between chi-square test and t-test?
Chi-square test is used for two categories, sir. Two category variables. But t-test is used to compare the means of two groups.
The answer for t-test is correct. In t-test only, the correct word he used, that is mean. I'll be finding the error around the mean. But in chi-square test, what I'll be doing?
Perform the
using-
hypothesis testing on two category variables.
Yes, Pujita, what is your answer?
element by element deviation.
Great.
Differences with n cap.
Great. Observation by observation, I'll be doing the testing. Whereas in t-testing, I'll take the mean and then do the testing. So that is actually the thing. So this you keep in mind very clearly. If I give any options can be there. T-test is there, what you should understand. Observation, or you say element by element checking. Whereas when I go for t-test kind of, you say that mean, right? Error around the mean, those things, right? So, and the formula for chi-square is O minus E the whole square divided by E, the raised to the entire summation, right? And you go to the chi-square table. And what is the degrees of freedom formula for chi-square testing?
N minus 1.
N
What is
minus
N?
Number of observed values.
Given by degree
Yes,
of
number of observations.
number
Great.
of observations.
And what is the best significance level for hypothesis
0.
testing?
0.01 to 0.05.
No, 0.1 to 0.5.
Okay. 0.1 to 0.5.
0.1 to 0.5. Shall I move to the next document? Is the document clear? I'll repeat one more time. So understand what is degrees of freedom formula, understand what is the best significance level, And if you are given with the chi-square metric, understand how for the given degrees
Sir,
of freedom.
up. Sir, once can you go up?
Yes.
That 15 significance value 15.9. This is not understand, sir. Once explain how this 15.9 came.
It is you are correct. It is 0.01 to 0.05. Now I say 15.09. Okay, I'll take the chi-square table. I have everything in the notes folder. Now, if I give you, let me give you a question. Okay, the chi-square value is given to you as some 7.23. That is the summation O minus E the whole square divided by E value is 7.23. And
Degree of
the
freedom.
numbers of degrees of freedom I will not give. I'll give the number of observations as 10. And your significance level alpha say 0.01. Now, what I'll do, what is the degrees of freedom now here? If n is equal to 10,
N minus 1, 9.
degrees of freedom is n minus 1. That is 10 minus 1 say 9. So for the degrees of freedom 9, this is actually the degrees of freedom 9. And my significance level says 0.01. So you search in this line, I am getting some value like 21.67. So I draw the chi-square distribution in the normal way. By 21.67 say it can be around here, 21.67. Where will be 7.23? Less than that or greater than that?
Less than
1.23 can be over here. Now
second.
the question, now there will be some hypothesis. You don't want to first understand what is given in H and R. Some H will be given. You just want to say whether the H is accepted or rejected. Now you say whether now you say for this is accept or reject. And this value, now I'll add one more point here. This is O minus E. This is actually the chi-square distribution formula. And if this value 7.23, say this time if it is not 7.23, if it is around some 27.23, now what you will do? Sometimes you may get accept, reject, or can't say none of the word like that. You say accept or reject, I accept or reject, like that only you say. Okay. Now,
Okay.
if it is 27.23 and 21.63, if it is 27.23, which is rejected, at that point, this particular value is called as critical value. If you are rejecting the hypothesis, then the chi-square value becomes a critical value. Critical chi-square value. 7.23 is not critical, but you are rejecting now. So this is actually a critical value. So at that point, if I ask you whether the given chi-square metric is critical or not, when you will say critical?
If it is not less than given.
Yes, if it is greater than the chi-square table value, then you say it is rejected or critical.
Critical.
Right? So is it clear, right? Shall I go to the next testing? So coming to the next T testing, I'm assuming that you are giving in a number of average number of customers buying a product is 160. So what is this value? 160. Mean, average number. That average in the sense mean. What is number of observations?
10.
10. And what is this standard deviation? Sigma. Now we need to calculate error around mean, and they are given the confidence level. One more thing. What is the formula for finding the significance level alpha? Significance level alpha is equal to 1 minus this confidence level. 1 minus confidence level is significance level. 1 minus 95% is 0.95. So what is 0.95? 1 minus 0.95 is 0.05.
0.05.
So what is this significance level formula? Right? You also note this. Okay. Now going to the problem actually, you do not write these many steps. Directly apply to this EBM formula. What is EBM formula? This then the T table with this significance level say alpha by 2. Why am I putting alpha by 2 is I'm going to do a two-tailed T test. I'm going to do a two-tailed T test. So in the value V. Now S by root n. S is actually the standard deviation that is given to me, and n is actually the number of observations. I got the number of observations as 10. So root 10 I have to take. Let us go to the values. 9 is the degrees of freedom for V I'm having, 0.05 by 2 I'm having, everything else is ready. Now go to the T table. Right. Yes. Now what will be the question? This is actually not straightforward. No table is involved. Directly within 30 seconds you should answer. Right. Now can if possible you say me the answer? Answer is 160. Mean is 160. You want to predict what will be the good mean value. N is 10 and this is 8.62. What is the formula for EBM?
Standard deviation by root of number of events. Sorry,
Yes,
number
divided
of
by
first
root 10 is correct. Very good.
root.
And before that, you need to take value from the T table also. In the T table, with the degrees of freedom V and alpha divided by 2, that is in the two-tailed inference, into this S by root 10, right? So I go to the T table with the number of degrees of freedoms as N and alpha, significant level alpha is 0.05 and I need to take alpha by 2. So what is alpha by 2? 0.05 by 2 is 0.025. I go to the T table. In T table, I have here, this is actually 0.025 I need to search. And my number of observations say N is equal to 10 minus 1, 9. Now in the significance level 0.025. What is the value I get here? 2.262. So that value I'll take. I'll go to this particular slide and see. Here in this 2.262, I multiply with 8.62. What is 8.62? 8.62 is given in the question as standard deviation. Divided by root 10. That is the number of observations. I do that. I get the value as 6.165. Then what is the error around the mean? The mean error can be 160 plus or minus 6.185, or that is it can be around 153 to 157 it can be. Now what will be my question is, I'll not be asking this and all. I'll be saying either this number 156 lies in the error bound or not. Whether
Yes, sir.
156 lies in the error bound or not. You say yes or no. You say yes or no like that. You need to calculate and say.
Yes, sir.
At that time, you should not be confused on how we have to find this and that. Just plus or minus 16.165 is there. So it means that less than that is 153 point something from that to 166.165 up to that error bound can be there. So whether this value will be in the bound or not, if you ask, you should say yes, true, or
Yes, sir.
accepted like that. You should be able to say, right? I'll be saying one more time also. So that is my dialogue. The dialogue slightly forget. So let us come to this question and go to the t-square normal testing. So this is error bound around the mean. What is the number of observation given here? Say the answer. I didn't show the answer here. You say me the answer. What is the formula? Can anyone say what is the formula? What is EBM? Formulas also you can be asked. Okay. So you understand the study the formulas also. What is EBM
S
formula?
by root n, S by root n, దాని తర్వాత వచ్చేసి T into V.
T with the units of
V
V
comma
comma alpha by 2. Great.
V1 comma alpha by 2.
Multiplied by S by root n.
S by
So
root n.
what is S here?
Standard
4.83.
deviation 4.8.
4.83. What is N here?
20.
So
20.
root
20.
20. And we need to calculate the T. What is V value? V is degrees of freedom. And again, degrees of freedom is N number of observations minus 1. Number of observation is 20. So 19 comma alpha by 2. Alpha is 10, 90. What is the significance level formula? Alpha is equal to
1 minus confidence.
1 minus confidence. 0.90. So that is 0.10.
0.10.
Divided by 2 will be
0.05.
0.05. Multiplied by S by root n. Now let us go into the T table now.
T19.
19, 0.5, 0.5 is here.
0.05.
0.05, 1.729. This value. 1.729 into 4.883 into divided root 10. The total calculations you can use the calculator and do. So we have this now, right? 1.729 into 4.83 by root 20. We had 1.867. So this is I can ask the error around the bean, or the question may be 79 is in the error bound or not. Now we'll proceed to the next things. So error bound around the mean is clear now. Yes. So the average number of people visiting this the product can be 79.23. Now acceptable. Sorry, this is actually the thing. Like this only I'm saying. 82 plus or minus 1.867. I'm saying the acceptable ranges are from 80.133 and 83.867. If I give 79.23, you should say not accepted or I rejected, like this. So this only you have said. So great. So with respect to EBM, we have completed. Right? Shall I go to the next thing? I'll say a small recap here. Here I have said three formulas. Formula number one is EBM is equal to t test of d comma alpha by 2 into s divided by root n. So s is the standard deviation, n is the number of observations, and v is the degrees of freedom, and alpha is the significance level. Next formula for significance level is 1 minus confidence, and if you want a two-tailed t test, you divide it by 2, right? And third one is the t table distribution. You go and see if the bound is actually within the particular range, then you say accept, else you reject the hypothesis, right? Shall I go to the next document? So when you are studying also, you go in the same way so that you can be easy to understand. Okay. Yes. Now one of you, that Pujita rightly said, it is going to be observation by observation in chi-square testing, whereas with respect to mean in t-square testing. Best example is there. Now before and after you'll be given some observations, and you don't think in mind that anyway I'm not going to give the table, so we don't want to read this. Anyway, if I give the last one, or if I ask you to do the table, anything can happen. Okay. So you first take the difference and square the difference. Difference is equal to average minus before, that is after minus before you take. Then you square the difference and keep everything, sum, mean, everything. What is the formula for t critical value? Like chi-square formula is O minus E the whole square divided by E raised to the entire summation. Likewise, what is the t formula? Summation d divided by square root of n summation d squared minus summation d the whole squared whole divided by n minus 1. So this is actually the formula for t square, t testing, sorry, chi-square, t square, t testing, student t testing, right? So you study this formula also. Same thing, you take the degrees of freedom and you take the values between those, and if it is was lying within this particular range, the t statistics what is lies. If it is lying in the less than the t table value, then it means that you can actually accept the hypothesis. Otherwise, you reject the hypothesis, right? Am I making it clear? You study this formula also. Now I will give you some series 1, 7, 13, 22, 30, 158, 42. What is an outlier here?
158.
Why?
This distant value, sir. That all range is very slow, but
If you take the mean of this, everyone will be having a constant number between the them. If you say 1 to 6 or 7 to 13 like that, some small deviations will be there,
Small
but this
difference
deviation is very high. So 150 is going to be an outlier. Like this, patterns will be there. And what are the ways are they exist to replace a missing value?
mean,
Again,
median mode.
Mean, median, mode, that is actually the statistical way. Second one, model based approach. I can develop a machine learning model for the missing column and train with the already available columns and predict these missing values and do. What is the difficulty with this particular way? This is high time complexity way. I cannot do this. It requires multiple models to be generated. So and another way is actually what the statistical methods, right? That is conditional mean, conditional mode, conditional median, those things and all. So those and all will be given. I'll be giving some distribution. You need to say what is an outlier there and what are the methods also. So if I ask you what are the methods available to clear a missing value, then you can say that there is statistical method. Next, what is the maximum value that you can substitute directly, or there is a machine learning model based approach is also available, right? That is actually with respect to missing data. Another thing about missing data analysis is outlier detection. That is, if you find a particular data not actually coming in the particular series, then you can say that that data as an outlier data, right? Those things, right? That is and all will come in the missing data analysis. In IBM slide itself, it is there. You don't have separate problems for that. And now quickly within that 10 minutes, I'll go to the unit 4. Unit 4 is very big. That is the notes. Bayesian. Let us complete back propagation first. See, in back propagation, how to calculate H1 recently we completed, so you answer quickly so that I can go to Bayesian. What is H1?
W11.
So one minute. Agendra alone is saying 5. Then you should not say women. Agendra is actually saying, so we are dominated like that. You should not say. Everyone can answer. Don't think that there will be only I1, I2. There can be something like I6 here. How many arrows you go here, you take that and multiply. Okay. For bias, there will not be weight. For other things, weight will be there. Right? That you can do, right? Based on the number of arrows that meet H1, H2 or something. And one more thing, don't think that only I1, I2, H1, H2, that names will be there. Names can be different. Don't think input will be I like that. A, B, C also I can give. Okay. And similarly, this particular diagram is given like this. And if I ask you to, I will not ask you to do that activations, everything and all. I just ask you to find, say H2, if I ask you to find, you calculate 0.05 into 0.25 plus 0.10 into 0.30 plus 0.35 will give me H2. That is called as net H2. What is out H2? Out H2 is you apply the logistic activation, that is 1 divided by 1 plus e power minus H2. That you do, then only you will get the output of H2. That you have to do. Then only the answer will be correct. See what is out H2 value. 1 divided by 1 plus e power minus net H2. That is what you have to do and get the answer. So these things you can do, right? Yes or no? We have still more things to discuss.
Yes, sir.
Yes. So these things will be there in neural networks, because if I ask you to do the back propagation completely, it is a 16 mark or 20 mark question. So don't. So you understand what are the concepts, everything. And Bayesian is missing. Where is Bayesian? Yes. This is actually, if a question is given now, these things will be given. If a diagram is given like this, now if I ask you, what will be the probability of playing tennis? Like this, if I ask you some probability, now we have to be in a thing to analyze and say what will be sunny, overcast, everything, and then say the result. For example, what is the probability for this? Outlook is equal to sunny, temperature is equal to 2, cool, humidity is equal to high, and wind is equal to strong. So what you will do, for temperature is equal to cool, how much is actually the value? Temperature is cooled is 3 by 9. So that value like that you have to take and you have to multiply and so. And outlook is equal to sunny, what is the value? 2 by 9. And humidity is equal to high means 3 by 9. Like that you have to take, multiply and then say the result. Just if you see down, everything need to be multiplied and the result should be same. For yes and no. For if a yes is high na, answer will be yes. If no is high na, answer will be no. For this particular instance, we get as no, so the answer is no. So those things. Right? Bayesian network formula very easy. Study the formula, understand what is the concept. Right? That probability where the tables can be given. This table may not be given. This is very big table. We cannot give this. But instead, this can be given. From this, we can be able to find, right, Bayesian formulas. Yes. With respect to nearest, I ask some normal questions. Which is the whether nearest neighbors use some decision trees and all only classification, no regression?
We can use regression also.
Both classification and regression. That's all.
Regression and
And
classification.
Yes. Which particular classification algorithm requires activation? SVM or neural networks?
Neural networks.
Yes,
Activate.
because only when activation is there, then it will is going to learn something deep, right? In SVM, which particular kernel is used for binomial things, binomial classification?
Sigmoid.
Sigmoid kernel is used for binomial classification. Great. If I go for what is the main use of random forest? Bagging is
Bagging
actually
and
the main thing.
aggregation.
So I need not to care about my model errors because many models are there. Surely any one model will be correct. So I can easily find that and put, right. And similarly, so far that's it. I hope you can actually I have shared all the codes, everything. This back propagation Bayesian I didn't share. I think so. I'll share now immediately after the class in the Google class. Everything is present there. So if you have any doubts during the exam, don't hesitate to call me and ask. Okay. Yes. All the best.